Atoms by numbers. We're going to talk about atomic number and atomic mass and a couple other properties of the atom. Last class we talked about the different atomic models, and so we're just going to relate a little more to the periodic table and some other information we can get and lead into our next unit. So you guys don't take this down, just I'll post it later so you guys can watch it. So hopefully by the end of this we know that atomic number is the number of protons, and we should understand that all atoms with the same number of protons have to be the same element. So that's what defines the atom, the number of protons. Atomic mass is a weighted average of all of a certain element. And we should be able to look at the periodic table and understand what the numbers are and where they came from. So if you take out your periodic table, guys, you might want to do that with me real quick, and I'll give you guys a second. So first periodic table was designed by Mendeleev. He grouped them by properties, similar to what that little card sorting activity that we did the other day. And interestingly enough, kind of how we did it, he actually predicted that there were elements before they existed. So he grouped them by properties. You might notice that you have hydrogen, lithium, sodium, potassium in the periodic table in the alkali metals column, and beryllium, magnesium, calcium, strontium. Those are the alkali earth metals. This is not perfect. It's not exactly how it came to be, but there are some similarities. But if you notice next to calcium, in between titanium, there's an element. So look in your periodic tables there right now. And he didn't discover this element, but he predicted by the properties there should be an element with atomic mass of about 44. And it turns out that scandium existed, and it was later discovered and had an atomic mass of about 45. So this is pretty amazing, and he predicted that a few other elements would exist as well. So it's pretty amazing that he was able to do that without even discovering the element. He predicted where it would be in its approximate atomic mass. So Mendeleev predicted it by atomic mass, and we'll talk later, right now, about Moseley. He arranged it by atomic number, by the number of protons or positive charges in the nucleus. And he unfortunately passed away in World War I at the ripe age of 28. So, yeah, poor guy. But he was a big contributor to how the periodic table is right now. Modern periodic table, we talked about this. We did our coloring. We colored the alkali metals, alkali earth metals. These are the transition metals. These are your lanthanides and actinides. Notice, guys, some periodic tables are different. I know our periodic table, lanthanum and actinium, are on column 3B. A lot of periodic tables, they have it in the separate column down here. So that's just, you really need to pay attention to that, and especially in our next unit. So, and they're grouped by properties. Discovery, interesting stuff about discovery periodic table. We knew a lot of elements from ancient times. We knew copper, we knew gold, we knew silver, we knew lead. Those were all elements that the ancient humans knew about. Sulfur was used in gunpowder. Iron, the Iron Age, was used to make weapons and tools and armor and spoons. From the Middle Ages to the mid-1800s, we discovered a lot of elements. That's when modern chemistry came to be. That's right after Dalton. Dalton was right on teaching chemistry to people, and a lot more discovered. We discovered a lot of elements. Notice what group is missing from here. Totally missing. The noble gases. We didn't know about the noble gases. Why? Because they were unreactive. We learn things based on their reactivity. And the noble gases were totally unreactive. We didn't know they existed. The first noble gas wasn't discovered until the late 1800s, and it wasn't even discovered on Earth. Helium was first discovered on the sun. Now, how they figured that out was, we took a look at the light that the sun produced. And we'll talk a little bit about light. Not too much this year, but a little bit. And every element produces a unique light spectrum. It produces a unique set of colors. So these crazy scientists, they took a look at the sun, and they looked at the light pattern, and they noticed these distinct patterns that were unlike any element that they had discovered yet. And that element was helium. That's where they got the name helium from the Greek god Helios. the god of the sun. So that's interesting. And it wasn't until much later, until the early 1900s, when we discovered the rest of the noble gases. Because, I mean, if they don't react with anything, you know, who knows they're there? Like ghosts. We don't know they're there. They could be right here. If they're not, well, we don't know. And the rest of the elements were discovered later. And they're actually trying to make some new elements. We're going to talk about nuclear chemistry later, but they're actually trying to make new elements right now, at this moment. Yeah. All those elements, like the unnamed, unidentified. So metals. You guys know the properties of metals. They're metally. Non-metals aren't metally, and they're metalloids, which are somewhere in between. Here are the metals. Here are the non-metals. They're the metalloids. Sometimes they're called semi-metals because they have properties of both metals and non-metals. The more metallic you get is the down and to the left of the periodic table. So you have francium down there. Take a look at that. That's extremely metallic. And then you have like helium, which is the least metallic element in the universe that we know of. So it's very non-metally. Hydrogen is actually somewhat metallic if it's a solid. It has to get really cold and really high pressure. So you'll never find solid hydrogen, and if you do, you'd probably die real soon. So we hope you don't find solid hydrogen. So noble gases, they don't really enter chemical reactions, and that's why I should have moved this slide up. But that's why they took so long to discover. But they're actually very useful. Like a lot of times they'll seal stuff. They'll seal stuff in noble gases and get rid of all the gases that would react with them. So they can get rid of all the oxygen. And in fact, that's a lot of the standard lengths and standard masses of S System International. They seal their things under argon, so it won't react. Information that you should know about the periodic table. From our periodic table specifically, there are other periodic tables. So you can get the symbol and the name. So the symbol is, every element has its own symbol. It's either one capital or one capital and one lowercase. So I'll talk about cobalt and carbon monoxide right now while you guys are copying this again. So not all periodic tables have the element name on them. Some of them just have the symbol. Other information that we can get, the atomic mass is the average mass of an element. And it's always the decimal number. Okay, that's the way you can always recognize that. Also, the atomic number, which is the number of protons. That's always the whole number. If you guys read left to right in your periodic table, it goes atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc., etc. Those are the numbers, the atomic numbers on the periodic table. So that's the number of protons, okay? So a couple key things right there. I'll pause it while we take this down, right? Moving on, subatomic particles. This is NTK information. Need to know. This is important, okay? So copy this down. Put it, I'm going to make a copy for you backwards so you can see it in the mirror when you wake up in the morning. Put it next to your bed at night. This is stuff that you should know. Yes, Jake? So protons and neutrons located in the nucleus, they have a mass of 1 atomic mass unit each. That's a relative mass. It's comparative. Now, electrons have about 1/2000th of an AMU of mass. But that's negligible, meaning it doesn't affect the mass of any element. So, and electrons are located in the electron cloud. What really makes a difference is the charge of the electron. It's a charge of -1, a relative charge of -1. Neutrons have no charge, and protons have a relative charge of +1. So that's the important information. So you guys can take a look at this. And what affects the mass of an atom? What two things, Lenny? What subatomic particles affect the mass of an atom?
Oh, the protons.
Protons and neutrons. And Felipe, what two subatomic particles affect the charge?
Protons and electrons.
Protons and electrons. So when you get this, the mass number of an atom is the protons plus the neutrons. Okay, so that's important. And the charge, I'll flip back in a second. The charge is the protons minus the electrons. Okay? A key thing, guys, mass number not in the periodic table. That has to be given. All right? So, charge, protons minus the electrons. Most in an atom, in a neutral atom, the charge is 0. What does that tell you about the protons and the electrons? They're equal. They're the same.